All right. So now let us try to solve this question. They say to us, find the general solution of this equation over here. Like I said, there are many different techniques that we can apply to determine the general solution of this equation, right? In this case, separable variables won't be able to work in this case, right? And then again, having a look at this differential equation, we can also try to check if linear will work. We can also try to check if the binomial will work. You'll just try everything. But what I can see is if me transposing this on the other side of the equation and me dividing by x, I can use my homogeneous first differential equation. I can use my homogeneous first order ordinary differential equation. Okay, if I apply that, remember the standard form is dy dx is equals to the function of maybe m with these two variables x and y, and then the function of p, x and y. It does not matter what the function is, but what matters is the function's supposed to have the same degree, okay? So now let us try to solve this question over here. So here, if we try to write this standard form, we can see that here we're going to have x dy over dx will be equals to, let's transpose everything on the other side of the equation. We're going to have positive y, subtract x. Therefore, let's divide both sides by x. Here we're going to have dy. dx will be equals to y subtract x divide by x. Are these two functions homogeneous? Yes, they are homogeneous because the degree of this exponent is 1. The degree of this exponent is 1. And then the degree of this exponent, not the degree of this exponent, the exponent or the degree of this function is 1. The degree of this function, it is also 1. Same applies to the, so that means we have 1, 1. So that means we have the homogeneous equation. And therefore, what is the technique? Remember what you're going to do here. We're going to have to let, right? So what are we going to let? We're going to have to let our y to be equals to vx. And then let's differentiate this. We're going to have dy over dx. Hold that to hold this side. We keep this constant. Differentiation of x is going to be 1. And therefore, we keep x now constant this side. The differentiation of v in respect to x, it will be dv over dx. Now, using this, we're going to do or perform a substitution onto our differential equation, our homogeneous differential equation. So now, performing substitution, dy over dx is equals to that. So that means we're going to have v plus x multiplied by dv divided by dx, which will be equals to, where we see y, now we're going to have to write the vx, right? We see y, so that means we're going to have vx subtract x divide by x. Taking x out of the bracket as a factorization, we're going to have x dv divide by dx, which will be equals to, here we're going to have v subtract 1 over 1, right? Because x will cancel that x when you take or we factor x outside of the bracket. And therefore, let's transpose v to the other side of the equation. Now here we're going to have the negative v. So this v and this v, they're going to cancel each other. Therefore, we're going to have dv over dx multiplied by x is equals to negative 1. And therefore, now we can separate these variables, separable variables. And therefore, here we can have just negative. It does not matter where you take your negative. So here we can have negative 1 dv, which will be equals to 1 over x dx. And therefore, from this step, what are we actually going to do? We're going to integrate both sides of the equation, right? Remember, we are looking for a general solution to an equation. Now, integrating both sides of the equation, what is the integral of negative 1? The integral of negative 1, in this case, you're going to have to bring v back. So that means you're going to have the negative v which will be equals to, what's the integral of 1 over x, natural log? It's going to be ln of x plus our constant in this case, which will be the c. We are not looking for v. Our general solution is supposed to be in these two variables, x as well as y. So now substituting v, we remember this can also be written as, let's make v subject of the formula. We're going to have y over x, which will be equals to v. So now here we're going to have negative y over x, which will be equals to the natural log of x plus c. And therefore this will be the general equation to this differential equation. So remember how you represent your final answer. It depends on the statement, right? You can just represent your answer like this. You can simplify it further, or explicitly, you can just make y subject of the formula. It really does not matter. It depends on the statement. If maybe you are told how to express your final answer.